Alright, so we're going to do one more example of calculation in Gaussian. So for this one, we're going to go ahead and do bond dissociation energy for ethane. So we already calculated ethane earlier, and still have that checkpoint file right here. So we already have that to compare it to. So now what we're going to do is we're going to find the energy of the methyl radical. So to do that, just create a methane here, and then we're going to delete that. So one thing we can do to actually make this job run faster is just because I already know the methane radical, it's actually going to form a planar molecule. So what I can do is come to this periodic table, select boron, because that's going to give me something that's already planar, and then select that, and then I just need to change that central atom to a carbon. So I'll come here, say I want a carbon atom, click the middle one, and now I have a nice trigonal planar carbon right there. And so this is going to be what my methyl radical is going to look like, and I can run my calculation on that. So I'll come here, say calculate, and then that first option. So this one, we're doing an optimization. We want to come to a minimum. So for our method, same thing we've been doing. Come say custom, additional keyword. So that's the same method, M062X, and then update. Alright, and then from there, so this has got just one single uncoupled electron, so that means the spin on this is a doublet, and the charge is 0, so it's still a neutral charge. And then we can, let's see, I think we just need to change our basis set, and then we want to have this as D once again, and then last thing is this guy over here, just get rid of him. And then this should all be good to go. So we'll submit that, and then we'll save this as methyl radical, which apparently already exists, so we're just going to override it and submit that and overwrite that. And here we go. So there's our checkpoint file. So each ethane that breaks is going to give us 2 of these. So when we go ahead and look at this energy, we're going to need to take that and double it. So we'll just highlight that if I can. There we go. Copy that. Stick that into our Excel spreadsheet. And then, so we get 2 of those per ethane. So we're going to multiply that by 2. So there's our total energy after we cleave the bond right there. And then if we come back to gausview, let's go ahead and we'll open our recent files. There's our ethane staggered checkpoint file. So we can take that, and then we can get the energy of that. So our summary, and then here's our energy right here. Stick that in our Excel spreadsheet, and now we just need to go ahead and find the difference between those two. So once again, take your higher energy one and subtract the ethane, so products minus reactants in this case. And then we get 0.163354 Hartrees, and then convert that to kilocalories per mole. So that's 627.5095 multiplied by this number here. And so we get out the energy to break a carbon-carbon bond in ethane is about 102 kilocalories per mole. And that should be pretty accurate if you go compare that with any sort of database that you'd find online. And so that would be all that you would do to compute a bond cleavage energy. I hope that was helpful.